Students, in previous class we have studied some of the problems on the Fourier transform, that is Fourier transform of various signals we have discussed in the previous class. In this class I am going to explain the two more problems on the Fourier transform. After that we are going to study the properties of the Fourier transform. So we know some of the properties we have studied in the first unit, such as linearity, time shifting, time scaling. All these operations we have to verify with respect to the Fourier transform in the third unit. So now I'm going to solve the two problems in this video. So Fourier transform, we know that it is a mathematical tool which is used to convert the time domain signal into the frequency domain signal. And after converting the time domain signal into the frequency domain signal, we have to plot the two graphs, such as called as amplitude spectrum, also called as magnitude spectrum, and another one we have to plot the spectrum that is called phase spectrum. So here, finding the Fourier transform of any given signal, we have to go through some various steps. First of all, we have to identify what exactly the x of t is. And then after that we have to apply the Fourier transform of that x of t. Then we have to go with the calculation of magnitude. Then we have to go through the calculation of phase. Then we have to plot amplitude spectrum and the magnitude spectrum. If you do all these steps in a sequence, you can get the maximum marks from the Fourier transform. So then I'm going to solve one of the important question which has been frequently asking in the previous university questions, that is find the Fourier transform of impulse signal. So first we have to know what is impulse signal. In the first unit we have studied the various basic signal, in which one of the basic and important signal is impulse signal. And impulse signal, we know that it is denoted with del of t. Del of t is equals to, we know that del of t is equals to 1 at t is equals to 0, and it is 0 for all the values of t except t is equals to 0. This is the mathematical representation of the impulse signal, and this is impulse signal is one of the basic signal we have studied in the first unit. It is denoted with the del of t, and del of t is equals to 1 at t is equals to 0, and 0 for t is not equals to 0. And now for this signal we have to calculate the Fourier transform. For this signal we have to calculate the Fourier transform. We know the standard formula for the Fourier transform, that is x of omega is equals to integral minus infinite to plus infinite x of t into e to the power of minus j omega t dt. It is the standard formula to obtain the Fourier transform of any given signal. Here the given signal we can assume that is x of t. Now in place of x of t, what we have? We have the del of t, that is nothing but impulse signal, and whose amplitude is 1 at t is equals to 0, and whose amplitude is 0 and all the remaining values of t except t is equals to 0. Then this is the thing, then we have to calculate the Fourier transform by substituting x of t by the del of t. Then I am going with the x of omega is equals to integral minus infinity to plus infinity. In place of x of t, what we have to substitute? We have to substitute del of t into e to the power of minus j omega t dt. That means what? We have to obtain the integration from minus infinite to plus infinite on the del of t, but the del of t is having the amplitude of 1 at t is equals to 0. Remaining all the values of t, that amplitude is 0, so that if we substitute minus infinite to plus infinite, we can have the value at t is equals to 0 only. Remaining all the values of t is not equals to 0, then we can have whose amplitude is 0. For that integration, anyway we will get the 0 only, so that no need to apply the integrals from minus infinite to plus infinite. We can apply the simplification at t is equals to 0 only, so that I am going with the at t is equals to 0, and del of t at t is equals to 0 whose amplitude is 1. If t is equals to 0, this will be e to the power of minus j omega, and we are saying that t is equals to 0. I am substituting t is equals to 0. This is at t is equals to 0 only, because impulse signal can have the amplitude at t is equals to 0 only, so that we no need to apply the integrations from the minus infinite to plus infinite. So now simplify this one. This is 1 into e power of 0. This will be the 0 e power of 0, so that anything power 0 will be 1 only, so that 1 into 1, so that we can have 1. Then what we got now? We got x of omega is equals to 1. So that from the introduction of the Fourier transform, we know that if x of t is a time domain signal on which we applied the Fourier transform, then the resultant signal will be the frequency domain signal. It is a time domain signal. That means what? Every amplitude of the signal is represented with the time on which we applied the Fourier transform, so that we can get the signal in the frequency domain. That means what? Every amplitude of the signal with respect to the frequency, that is angular frequency, is denoted with omega. Then in place of x of t, what we substituted? In place of x of t, we have substituted del of t, that is a unit impulse signal on which we applied the Fourier transform. Then what we got? The Fourier transform we got is about 1. So now this 1 is the free from the time domain, so that we can call it is a frequency domain signal. So by applying the Fourier transform on the impulse signal, we can get the frequency domain signal, that is 1. Now this is what? It is obtaining the Fourier transform of the impulse signal. But in complete Fourier transform, we have to plot the two spectrums. One is a magnitude spectrum, also called as amplitude spectrum. Another one is a phase spectrum. Now amplitude spectrum is nothing but it is the plot between the magnitude of x of omega, versus omega. It is a plot between magnitude of x of omega versus omega, so that I can take this is a magnitude of x of omega versus omega. First of all, we have to calculate what is the magnitude of x of omega. Once we know this magnitude of x of omega, we can easily plot the amplitude spectrum. So that magnitude of x of omega is given by modulus of x of omega is equals to under root of xr square of omega plus xi square of omega, where xr square of omega is nothing but it is the real part of x of omega, and xi of omega is nothing but it is the imaginary part of x of omega. Here in the x of omega, what we have? X of omega, we have only 1 only. In this, there is no imaginary part. Imaginary part means the part which is associated with the j term, we can call it is the imaginary part. There is no j term, so that imaginary part is 0. That means what? This part, xi part is 0, and we have the real part is 1. So that here, if I substitute xr is 1, so that 1 square will be 1 only, and that under root of 1 will be 1 only, so that I can get the magnitude of x of omega is 1 for all the values of omega. That means what? X of omega we got, modulus of x of omega we got, that is 1 for all the values of omega. Then you can plot the magnitude spectrum or amplitude spectrum. Now I am going to plot the magnitude spectrum or amplitude spectrum for all the values of omega. That means what? This is the plus omega, and this will be the minus omega. For all the values of omega, the magnitude is 1 only, so that I can have here this is 1, so that I can have the signal is for all the values of omega whose amplitude is 1 only, such that you can plot that amplitude spectrum. This is the amplitude spectrum of that particular unit impulse signal when we apply the Fourier transform on the given signal. So that this is what here, this is having the amplitude, it is having the amplitude of 1, magnitude of 1 for all the values of omega, so that it is called, it is the amplitude spectrum or the magnitude spectrum. Magnitude spectrum is nothing but it is a plot between, the magnitude of the x of omega versus omega. This is nothing but amplitude spectrum, also called as a magnitude spectrum. Next we have to plot the phase spectrum. Phase spectrum is nothing but it is a plot between, or it is a graph between angle of x of omega versus omega. First of all, we have to calculate angle of x of omega. After that, we have to plot the graph between angle of x of omega versus omega. Now I can take this is angle of x of omega, and this will be the omega. First of all, I must calculate what is angle of x of omega. We have the formula, that is angle of x of omega is equals to tan inverse of xi of omega by xr of omega. That means what? Xi of omega is nothing but what? It is the imaginary part of x of omega. Xr of omega is nothing but it is the real part of x of omega. Anyway, there is no imaginary part, so that we can treat this is 0. 0 by anything will be 0 only, so that I can write this is tan inverse of 0. 0 by anything will be 0 only. Tan inverse of 0, and we can have that angle is about 0 only. Tan inverse of 0, someone can ask tan inverse of 0 will be, how it will be 0? You can write this one is tan inverse of 0. I can write that is tan 0 also 0. Tan inverse and tan is get cancelled, and so that I can left with the 0 radians only. So now here it is 0 radians. That means what? The angle, that phase angle of that Fourier transform of impulse signal is about 0 for all the values of omega. Then whatever may be the value of omega, whose phase angle is 0 only. Now I can go with this is the positive omega, and it is the negative omega. Whatever may be the value of omega, the phase angle is we got 0 only. That 0 is whatever may be the values of omega, phase angle is 0 only, so that this line is represent that phase angle is 0. Whatever may be the values of omega, we got the phase angle is 0, so that this plot is called as a phase spectrum. So it is very clear that first of all we have to identify what exactly the x of t. After that, we have to perform the Fourier transform by making use of the standard formula. After that, we must get the Fourier transform. Then we have to plot the two spectrums. One is a amplitude spectrum, and the another one is a phase spectrum. In amplitude spectrum, we have to plot the graph between the magnitude versus omega, and in a phase spectrum we have to plot the graph between the phase angle versus omega. And if you solve all this, if you solve the Fourier transform with all these steps, you can get the maximum marks from the exam. So that I am going to solve one more problem based on this Fourier transform, so that everyone is going to clear with the Fourier transform. After completion of this one, we are going to see the properties of Fourier transform. Then I am going with the one more problem, that is a Fourier transform of double-sided function, that is given as x of t is equals to e to the power of minus a into modulus of t. So this is the question we have. This is the question we have. For this question, we have to calculate the Fourier transform. After that, we have to plot the magnitude spectrum and the phase spectrums, so that you can, by plotting all these spectrums, that is magnitude spectrum and the phase spectrum, you can successfully complete the Fourier transform of the given signal. So then second question is what? Find the Fourier transform of double-sided. Double-sided means signal is there in the first quadrant and as well as a second quadrant. Find the Fourier transform of double-sided function, that is x of t is equals to e to the power of minus a into t. So that in the question itself it is saying that it is a double-sided, so that I can write this is x of t is equals to, I can write x of t is equals to, I am converting this is into the double sided by substituting t is equals to positive and t is equals to negative. I can get the double sided x of t. X of t is equals to e to the power of minus a into minus t is equals to what I can get? E to the power of minus a into minus t, that will be e to the power of a t only for t less than 0. T less than 0 means what? T is a negative. Then I can substitute the another one e to the power of minus a as it is there. Then I am taking the t is positive, so that it will be e to the power of minus a t for t greater than 0. Greater than 0 means it is positive. Again I can get one more condition, at t is equals to 0, e to the power of minus a into t is 0, so that I can write e power of 0 will be 1, so that at t is equals to 0. At t is equals to 0. For these three cases we have to find out the Fourier transform of x of t. Now the x of t is this one. For this we have to calculate the Fourier transform. Then I am going with the standard formula. What is the standard formula for achieving the Fourier transform? X of omega is equals to integral minus infinity to plus infinity x of t into e to the power of minus j omega t dt. This is the standard formula. Now based on our three cases, I can split this integration, so that x of omega is equals to, and this is the value for all the negative values of t, so that I can go for minus infinity to minus 0 minus. So that I can write here this is about for t is negative, what is the signal? That is e to the power of a t into e to the power of minus j omega t dt. At t is equals to 0 also it is having, so that it is integral 0 minus to 0 plus, at the t is equals to 0, what is the amplitude? We have that is about 1 into e to the power of minus j omega t dt. Then another third case is what? That is for the t is positive values, that is 0 plus 2 plus infinity, that is what is the signal? That is e to the power of minus a t into e to the power of minus j omega t into dt. So based on the given signal, I have I split these integrations into three integrations. One is minus infinity to 0 minus, so that all the negative values can come here, and the next one at 0 this integration will do that, and for 0 plus to the infinity, that will be the values for all the t greater than 0. Now I can go with the integration, so that here this is what? It is integral minus infinity to 0 minus, and here bases are same, so that we can add the power. So power should be added, so that I can write e to the power of a minus j omega, and here t is also common, so that I can write this is e to the power of a minus j omega t into dt. Anyway, here we are having the upper limit is 0 and the upper limit and the lower limits also 0, so that whatever we achieve the integration, After getting the integration, we have to substitute the upper limit is 0 and the lower limit is 0, so that the both will get the same value, so that 0 minus 0, that will be the 0 only, so that no need to do the integration of this part, so that you will get it is 0. You will get it is 0, so that no need to concentrate that one. And the next term is what? It is integral 0 plus 2. It is integral 0 plus 2 infinity e to the power of, and here the also bases are same, so that we can add, the power should be added, minus is common, so that a plus j omega t into dt. Then if you perform the integration on this one, we can have the, that is about e to the power of a minus j omega t by, again we have to do the integration, that is a minus j omega, limits will be, that is minus infinity to 0 plus, and here also we can achieve the integration, that is e to the power of minus a plus j omega into t by the minus a plus j omega, and then we can have the limits are what? 0 to infinity. Then by substituting this one, you can get here, this is what? Here substitute the upper limit, that is at the t is equals to 0, we have to substitute, so that you can get this is e power of 0, and after that you have to substitute e power of at t is equals to infinity, you have to substitute, so that e power of minus infinity by the denominator remains same, that is a minus j omega, plus here also you can get e to the power of, first upper limit is infinity, minus lower limit is 0 by the minus a plus j omega, so that e power of 0 will be 1, and 1 minus this will be 0, and coming to here, this e power of infinity will be 0 minus, and this will be 1, so that here you will be getting the minus 1 by minus, so that minus get cancelled. Here you will get the 1 by a minus j omega plus here 1 by a plus j omega you will get, so that here you will get 1 by a minus j omega plus 1 by a plus j omega you will get. Then by cross multiplication, by the cross multiplication, you can get the x of omega is equals to, we can have 2a by a square plus omega square, we can get a square by a 2a by a square plus 2 a square plus omega square, you can get, this is nothing but what? Fourier transform of the given signal. And after calculating the Fourier transform of given signal, what we have to plot? One is magnitude spectrum, another one is phase spectrum. We know that magnitude spectrum, it is a plot between the magnitude of x of omega. This is a magnitude of x of omega versus omega. That is magnitude spectrum. Coming to the phase spectrum, it is a plot between the phase angle of x of omega versus omega we have to plot, so that it is a plot between magnitude of x of omega versus omega, and here it is a plot between angle of x of omega versus omega. Then first we have to calculate magnitude of x of omega. We know the formula, magnitude of x of omega is equals to under root of x r square of omega plus x I square of omega. Then real part and the imaginary part we have to go. Then by calculating the real part and the imaginary part, you can have this one is about here, this is what? Here there is no imaginary part we have. There is no imaginary part. So that whatever we had, that is only the real part. So that we are squaring that one, and this is under root is there square, and the under root square root can be cancelled. So that you can get, that is 2a by a square plus omega square only. And coming to the phase angle, what is the formula for phase angle? Angle of x of omega is equals to tan inverse of x I of omega by x r of omega. There is no imaginary part, so that this will be 0. 0 by anything will be 0, so that tan inverse of 0 will be 0 degrees only, so that you can get here it is 0 degree radians. So that means what? Now we have to plot the graph. Now we have to plot the magnitude spectrum and the phase spectrum. That means what? By substituting. Now assume the A is equals to 1 and substitute various values of omega. Various values of omega on the x-axis on left side and the right side. So that anyway we kept A is equals to 1 by substituting A is equals to 1. 2 into 1 and 2 into 1, 2 by 1 square, that is 1 plus substitute various values of omega here 0, 1, 2, 3 like that you can substitute such that you can get the signal is like this. It is very similar to the Gaussian functions you can get. In the last class I have explained the Gaussian function by substituting the various values of omega, and we can get the phase magnitude spectrum. That is nothing but it is a Gaussian function. Gaussian function is denoted with GAS of t. We have studied this is nothing but the magnitude spectrum of the double-sided x of t is equals to e to the power of minus a into t. Then we have to plot the one more spectrum, that is nothing but it is the phase spectrum. Phase spectrum is nothing but it is a plot between angle of x of omega versus omega. This is angle of x of omega we got, that is 0 degrees. Then for this is for all the values of omega, because there is no imaginary part. This part is there is no imaginary part, so that xi is equals to 0. So that if I substitute it is xi is equals to 0, tan inverse of 0 by anything will be 0 only. Tan inverse of 0 will be 0 degree radians only. So that for all the values of omega, what is the phase angle we got? For all the values of omega, we got the phase angle. Is 0 only. So that from the definition of the phase spectrum, it is clear that it is a plot between the phase angle versus omega. So that this is the magnitude spectrum and this is the phase spectrum, such that we can solve any problem based on the Fourier transform. Anyway, whatever the material I shared with you in the previous classes, in that I have discussed around the 7 to 8 problems on the Fourier transform, so that everyone go through those problems such that you will be perfect in getting the Fourier transform of any kind of signal. The points to be noted here: first one, everyone has to identify what exactly the x of t. After that we have to calculate x of omega by using the standard formula, that is integral minus infinity to plus infinity x of t into e to the power of minus j omega t dt. After calculating the x of omega, then we have to go for the magnitude spectrum, and after that phase spectrum. Magnitude spectrum is nothing but it is a plot between the magnitude of x of omega versus omega. Then this is a magnitude can be calculated. Modulus of x of omega will be under root of x r square of omega plus x I square of omega. This is the real part of x of omega and it is the imaginary part of x of omega. Imaginary part is nothing but the term which is associated with the j term. The term which is associated with the j term is called the imaginary part. So that there is no imaginary part, and here we have to square the real part, so that we have to square this one, and that is there in the under root, so that square root and the square will get cancelled. It remains the 2a by a square plus omega square only. So that it is what? It is the magnitude at all the values of omega. It is our magnitude at all the values of omega. So that substitute all the values, various values of omega, and such that you will get the answer is like this. For example, substitute a is equals to 1 and omega is equals to 0. A is equals to 1 and omega is equals to 0 means 2 1. 2 into 1, that is 2 by 1. 2 by 1 only. That means what? The maximum amplitude is 2 here I can get. If A is equals to 1 and the omega is equals to 0, maximum amplitude I can get is 2. And as the omega value increases in the positive and in the negative direction, then that magnitude is going to reduces, that signal strength is going to reduces. That function is called as Gaussian function. Anyway, we have studied this Gaussian function in the previous class. Next one is what? Phase spectrum. It is a plot between the angle of x of omega versus omega. Angle of phase angle is nothing but angle of x of omega is equals to tan inverse of imaginary part by the real part. Anyway, imaginary part is 0. 0 by anything will be 0, so that you can get the phase angle is 0 for all the values of omega. Like that, we can easily plot the magnitude spectrum and phase spectrum. In tomorrow's class, I'm going to discuss in the tomorrow's class. Anyway, we are not having the class tomorrow, but I'm going to I'll try to send I'll try to share one video that is used to describe the properties of Fourier transform. And in the third unit, from the Fourier transform, we can expect the two kinds of questions only. One is find the Fourier transform of given signal, first question. Second question, explain any 4 to 5 properties of Fourier transform. This is a damn sure question. These two kinds of questions can be asked in the Fourier transform. So that first part is completed. Second part, we have to focus on the properties of Fourier transform. With that, everyone will be good at the Fourier transform. Thank you, students.